Hi everyone, welcome to my channel. Today's problem, LeetCode daily problem, is an easy one, but I wanted to discuss it because it has an interesting solution. So the problem is easy, as I said. You are given an integer n, and you should return true if that n is a power of 2 and return false otherwise. And a power of 2 is, the definition is the n is a power of 2, for some x, for some integer x. The straightforward solution would be a for loop. You can just do a for loop and keep dividing your input by 2 until you reach 1. So if you do that, for example, for 16, it's going to become 8, 4, 2, and then 1. But if you do that for 40, it's going to become 20, 10, 5, and that's it. You cannot go any further. So with a for loop, you can easily manage to do that. But here, the problem is asking, could you solve it without for loops and without recursion? And this is the solution that we are going to be talking about. So when they ask you not to use for loops or recursions, they are asking for O1. So instead of O of log n, which is you repeatedly divide the input by 2, instead of that, the problem is asking for O of 1 probably. And whenever you are asked to do something in O of 1, the only operations that you can do are the bitwise operations like AND, OR, XOR, or NOT, or the binary operations like plus, minus, etc. Addition and subtraction, sorry. So how do we do that? So the idea would be here, let's have a number that is a power of 2 and a number that is not a power of 2 and see what we can do. So if a number is a power of 2, let's say this is 1 and all of them are 0, for example. I'm working with the binary representation of a number because it's going to be easier. We may need to use some of the bitwise operations, so that's why I'm doing it with the binary operation. The binary representation. So the other number, for example, you have a 1 here and you also have a 1 here and here. So obviously the answer for the upper number would be true and the answer for this one would be false, right? So the idea should be something like this. I want to get rid of this one somehow, get rid of this one, and see if I have any other set bits to the left of this one. So this is the idea. Destroy or get rid of the rightmost set bit and see if there are any other set bits out there. This is the idea. But how do we get rid of the rightmost set bit? So if you have worked with binary representations, this should probably come to you, but again, it's not an easy thing to come up with. So whenever you have 2 to the n minus 1, if you have 2 to the n and you subtract 1 from that number, what you will have is going to be a beautiful representation in binary representation. So in this example, it's going to be something like this. So you got rid of that set bit, you got rid of this set bit, and this is going to become 0, and any other bit after that is going to become 1. And now if you AND the two numbers, you are getting rid of everything here. So basically, if you AND these two numbers, here all of them would be 0. So 0, 0, 0, 0. But something good happens because everything else here is also 0. This is 0, this is 0. And your AND operation is gonna result in all of them being 0. But in a number that is not a power of 2, here, let me have this. So here, this is gonna be 0, this is gonna be 1, this is gonna be 1, and this is gonna be 1. Okay, but here, this is still gonna be 1. This is still gonna be 1. Because we only got rid of the rightmost set bit. We didn't touch the rest of the bits, right? We didn't touch the rest of the bits. So when we do an AND operation, this is going to be 0, this is going to be 0, 0, 0, up until the first set bit. But here, we will have some 1s. And that is the beauty of this. So the answer would be n and n minus 1 should be equal to 0. That's it. That's it. If it's 0, it's a power of 2. If it's not, that means we have some set bits here still hanging there. The code should be super easy. We just need to check for the number to be positive as well. So return n greater than 0 and n minus 1. Okay, this should be 0. That's it. You just run it and submit. So think about this solution a little more, and this the beauty of like subtracting 1 from the number. And then what I suggest you do is you implement this solution with a recursive approach. This is a good practice of thinking recursively. Thank you.